All right, in this example, we're going to find the displacement and distance traveled given a object is moving in a straight line with this velocity function. So what we're going to do is find the first antiderivative of the velocity function to get the position function. So your position function will be, we're going to raise the exponent by 1 and divide by that exponent. Raise this exponent by 1. When you divide by 2, you get -1 in front. Give 8 a variable, and then you're going to have plus a constant, but in this case they don't give you a constant, so you'll just assume that it is 0. So we have our position function, and then we're going to start by finding the displacement by taking, so we just did the integration of the velocity. And we're going to go from 1 to 6, which was the time interval given to us. So now we have this position function, and we're going to plug in 1 and 6. And then we're going to subtract those values. So we're going to start by plugging in 6 into the function. We're going to get a solution for that. Then we're going to plug in 1 to the function and get a solution for that. And then we're going to subtract those two values. So go ahead and figure those out. So when I plugged in 6, I ended up getting 72, -36, -48. When you plug in 1, I'm getting 1/3, -1, and -8. Then when you, I got a common denominator over here, got it down to 26/3. Over here we get 12, and then when you get a common denominator and add, you're going to get -10/3 for the displacement. So that is your displacement. That's how far we are in terms of, I want to say it's in meters. I'm not sure if they said, but that would be meters away from where we started. Then distance traveled, you're going to have to make sure that each distance you have remains positive. So in order to do that, we need to know when is the velocity function going to turn negative. So we're going to set that equal to 0. And that is going to tell me where the function hits the x-axis and where it would change from positive to negative. So you're looking for numbers that multiply to make -8 and add up to -2. So you can factor this into t minus 4, t plus 2. And then if you set each of those equal to 0, we're going to get 4 seconds and -2 seconds. The only one we care about is 4, because that is in the time interval 1 to 6 that they gave you. So you're splitting your time into 2 intervals. You're going to go from 1 to 4, and then we're going to look at 4 to 6, and then we're going to see where is it negative, where is it positive. You could graph this function, or you could just test a number and see whether it's going to be positive or negative there. Testing is probably the quickest way to do it. So if you plug in 2 seconds, which is between 1 and 4, you're going to get 4 minus 4, which is 0 minus 8, so this is the negative section. Over here, if you plug in 5, which is between 4 and 6, you're going to get 25 minus 10 minus 8, which is going to be your positive section. So when we do our integration of the velocity, you're going to make sure that you do absolute value of this velocity from 1 to 4. And then over here, you don't need to worry about the absolute value because it'll be positive. You can put absolute value on it if you want, but you don't need to worry about it. All right, so then from there, we're going to look back at the position function that we found. So we're going to plug in 4 and 1, get an answer, and make sure it turns positive. Then we're going to plug in 4 and 6, get an answer, and make sure that it's positive. So here are my calculations for this next section of the problem. So we've got from 1 to 4, we're going to find the area under the curve for the velocity function, which would be your position function with the upper limit of integration plugged in. So plug in your 4. So that's why I've got my position function was 1/3 t cubed minus t squared minus 8t. So you're seeing 1/3 4 cubed minus 4 squared minus 8 times 4, because that's the top number on your integration sign, minus you take the position function and plug in 1. So you've got 1/3 times 1 cubed minus 1 squared minus 8 times 1. Whatever that value is, you're going to take absolute value of it because you want it to be a positive distance. Then you're going to add the distance from 6 to 4 seconds. So you plug 6 seconds into your position function, you're going to get 1/3 6 cubed minus 6 squared minus 8 times 6. Then you're going to plug in 4, 1/3 4 cubed minus 4 squared minus 8 times 4. You're going to get an answer for this, and you're going to make sure you take the absolute value so that it is a positive distance. And then we're going to add them together. So now let's go ahead and start calculating that. So for 4, I'm getting 64/3 minus 16 minus 32. For the 1, I'm getting 1/3 minus 1 minus 8, and we've done this earlier in part A. For 6, I'm getting 72 minus 36 minus 48, which we also did earlier in part A. And then for 4, same as before, I'm getting 64/3 minus 16 minus 32. Now let's put all those together. For your first value, I'm getting negative 80/3. For the 1, which we did earlier, negative 26/3. For the 6, which we did earlier, is negative 12. And then same thing as first part, for the 4, you're getting negative 80/3. Then put those together. From here, I'm getting negative 18 and positive 44/3, which we knew was going to happen. We knew this was our negative section and this was our positive section. So you're going to end up getting positive 18 plus 44/3. That will give you 93/3 is the total distance traveled, not the displacement, but the total distance traveled. So we went in a negative direction at first, and then we went in a positive direction, and it's adding up the absolute value of those distances traveled. So 93/3 is your total distance.